Tell me. Or extent of reaction. Weber. What is extent of reaction or reaction coordinate? Siddhi. When I take your name, at least respond. I don't know. I don't remember. I need some response when I take a name. Silence is not an answer. Silence means you are
Sir,
thinking.
sir, maybe the reaction takes place till that extent, like equilibrium criteria.
It's not equilibrium criteria. What is the definition? Just give an equation for that. We have seen that equation, right? We have defined what is the extent of reaction or reaction coordinate. Shivani?
सर रिएक्शन की प्रोग्रेस कितनी हुई है वो डिफाइन करते हैं.
Right. So simple. Extent of reaction means कितना progress हुआ, कितना react हुआ. We have seen conversion in PC, right? What is conversion? याद है किसी को PC में क्या था conversion? Gauri? Nobody remembers. Viraj?
How much the compound is reacted or consumed.
Right. So let us define what is conversion. Okay. Let's see. How was it defined in PC? Okay. What is the definition of conversion? किसी को याद है?
Sir, reacted upon fed. Means reactant reacted by.
So first thing is we need to identify what is the limiting reactant. याद है किसी को what is limiting reactant? Nobody remembers.
Reactant which gets first consumed in the reaction.
Right. पाव भाजी का एग्जाम्पल आपको दिया था, इतना अच्छा एग्जाम्पल है. You should be remembering all that, right? But आपको पसंद नहीं है शायद एग्जाम्पल वो. So moles of limiting reactant consumed or reacted divided by moles of limiting reactant in feed. आपको पहले बोला था पीसी कभी नहीं भूलने का, जहां भी जाओगे आपको पीसी कहीं नहीं छोड़ेगा. You can use it or it will be required everywhere and every subject. As chemical engineers, PC should be in your blood. If it's not, then there's a problem. Blood test कराना पड़ेगा. ठीक है? So that is conversion. That is how it was defined in PC. Extent of reaction is related to this. We'll see the relation also. But we have defined extent of reaction as extent of reaction or reaction coordinate is defined as dni by nu I. dni is number of moles of any component which have been consumed or formed, doesn't matter. It's a change in number of moles of component I divided by nu I. What is nu I? What is nu I?
Stoichiometric.
Stoichiometric coefficient or stoichiometric number. They call it here stoichiometric number. It's actually stoichiometric coefficient that you use in PC. So d epsilon is extent of reaction, or epsilon is extent of reaction, and d epsilon is dni by nu. And we have seen that dna upon nu a is equal to dnb upon nu b is equal to dnl upon nu l upon d is equal to dnm upon nu m. That means for reactant as well as for product, if you take the ratio of change in number of moles and divide it by the stoichiometric number or stoichiometric coefficient, you'll get the same value, right? And that is d epsilon. And that's how we define the reaction coordinate or extent of reaction. Any questions on this basic definition? Because it's going to be used extensively in units 5 and 6. And if you don't understand this, you will not understand what we are going to see in these units. Okay. So epsilon measures the progress of reaction, defined as degree to which reaction has advanced or completed. So advantage is change in reaction coordinate or extent of reaction is same for each component. That's what we saw, that dni upon nu I is constant, right? But change in number of moles are different for different species in the ratio, because nu I is different for each species, right? So that was our definition, and I had given an assignment homework किसी ने किया नहीं है, so it's pathetic, but carry on being pathetic. So let us look at the relation between mole fraction and extent of reaction, right? So we have defined dni is equal to nu I into d epsilon, and if you integrate this from start time equal to 0 to time equal to t, right? When at time t equal to 0, the extent of reaction is 0, there's no reaction, and at time equal to t, that extent of reaction is epsilon. Initial moles is ni 0 and final moles is ni. So if we integrate this, we'll get ni minus ni 0 is equal to, on the right hand side, nu I is constant into epsilon, right? And from here we get ni equal to ni 0 plus nu I into epsilon, equation 1. Okay, so yi is mole fraction of component I in reaction mixture, and what is yi? Is number of moles of component I divided by total number of moles. Okay, so if we put substitute for ni from equation 1, we'll get ni 0 plus nu I into epsilon, and in the denominator will be summation of all the component moles, which is summation of ni 0 plus nu I epsilon. And we know that if you take summation of all the components at the starting point at time t equal to 0, it is total number of moles at 0, at time 0. So we can write yi is equal to ni 0 plus nu I epsilon upon the denominator summation of ni 0 is n0 plus summation of nu I into epsilon. And we can add all the nu i's, and that is also summation of nu I is equal to nu. So we get yi is equal to ni0 upon ni0 plus nu I into epsilon upon n0 plus nu into epsilon. So if you know epsilon, we can find out yi. Any questions on this? Equation 2. Okay, so if there are no questions, let us do that example which I had given you as homework, which nobody did. So example 9.1. Can you see this?
Yes, sir.
Yes, sir.
So derive the relationship between mole fraction of the components taking part in the reaction and extent of reaction. ये तो हमने किया है, okay. ये अभी किया हमने. So let's do example 9.2. Gas mixture contains 2 moles nitrogen, 7 moles hydrogen, 1 mole ammonia initially. That means at time t equal to 0, and is undergoing the following reaction: nitrogen plus N2 plus 3H2 gives 2NH3. Derive the expression for mole fractions of various components in the reaction mixture in the terms of extent of reaction, right? So that means we have to find out why nitrogen, why hydrogen, why ammonia. So let's do this part A first. ये आपको इक्वेशन दिया है यहाँ पर 9.4, इसमें सिर्फ सब्स्टिट्यूट करने का है to find out why ammonia, why hydrogen, why nitrogen. Let's do it. This is only 1 minute question. करो अभी. Already you can see N0 is equal to summation of Ni0, that means 2 moles of nitrogen initially plus 7 moles of hydrogen plus 1 mole of ammonia, that is 10, and summation of nu I is product के लिए positive रहता है, so 2, and reactants के लिए negative रहता है, so -1 and -3, that is -2. So N0 is given, nu is also given. Just find out what is why nitrogen, why hydrogen, why ammonia using this equation 9.4 and the data.
एप्सिलॉन के फॉर्म में क्या?
हाँ, एप्सिलॉन के फॉर्म में, एप्सिलॉन के फॉर्म में रहेगा. एप्सिलॉन इज नॉट नोन, so we have to find out why as a function of epsilon. Okay, करो. This example 9.1 जो मैंने derive किया अभी has appeared in exam, final exam sometime in the past. Find out what is why nitrogen, why hydrogen, and why ammonia in terms of epsilon. इसका हो गया और हैंड रेस करेगा. Okay, so what is why nitrogen, Vaibhav? शिवानी को ही बता
सर
सकता
2
है.
माइनस एप्सिलॉन बाय 10 minus 2 एप्सिलॉन.
Okay, शिवानी, why hydrogen?
7 minus 3 epsilon upon 10 minus 2 epsilon.
Okay, Dikshita, why not ammonia?
One plus two epsilon upon 10 minus 2 epsilon.
Good. सिंपल सब्स्टिट्यूशन था, इसमें ज़्यादा कुछ करना ही नहीं था. But if you observe, the denominator is going to be remain same because that is total number of moles at any time. So denominator रहने वाला, only numerator is going to change because numerator is number of moles of that component, nitrogen, hydrogen, or ammonia. Denominator is total number of moles. Total number of moles is always going to remain constant as a function of epsilon. So denominator same ही रहेगा सब जगह, only numerator will change. ठीक है? So let's continue from there. Okay, so next we'll find out what is the relation between conversion which we defined in PC and extent of reaction, because they are related. They are almost two ways of representing the same thing. Okay, so in this case we used to define X as conversion. Here is defined as Z. Fractional conversion of limiting reactant is nothing but moles of limiting reactant reacted or consumed divided by moles of limiting reactant in field. Right? So moles of limiting reactant consumed is going to be Z into initial moles, that is Ni0, limiting reactant in field, right? Where Ni0 is moles of limiting reactant in field. And the moles of limiting reactant unreacted will be Ni equal to Ni0 minus how much has reacted, Z into Ni0. Okay? And equation 1 we have derived that Ni is equal to Ni0 plus nu I into epsilon. So if we compare these two equations, left hand side is same, so you can say Z into Ni0 is equal to Ni0 plus nu I into epsilon. Ni0 cancels out, and what we get is Z is equal to minus nu I epsilon upon Ni0. Any questions on equation 4?
Sir, what is the difference between conversion and extent of reaction?
यही तो equation है. Shows that relation between Z and epsilon. वही कर रहे हैं हम भाई. Because there is a two ways of defining the same thing, but there is a relation between them. They are not independent of each other. They are, if you know one, you can calculate the other one. And that's what the relation 4 shows, equation 4 shows. Conversion is equal to minus nu I into epsilon upon Ni0. So if you know nu I, you know Ni0 and epsilon, you can find out Z. Nu I is always known for a reaction. Ni0 is also known for a reaction, right? And if you know epsilon, you can find out Z. Does that answer your question?
But sir, means difference समझ में नहीं आया.
Difference is definition different है ना. Epsilon कैसे define किया हमने? How is epsilon defined? Epsilon is defined
Degree
by
2.
dni by nu I, right? कितना moles change हुआ divided by stoichiometric coefficient. That is the definition of epsilon, d epsilon or epsilon, doesn't matter. Change in number of moles divided by nu I. Conversion कैसे define किया हमने? Is the ratio of feed में कितना था. समझ में आ रही बात? So there are two different ways of defining. Thermo में ऐसे define किया because they have some uses in thermo. But there's a relation between them. If I know conversion, I can find out epsilon. If I know epsilon, I can find out conversion. Still confusion है क्या दीक्षिता?
Yes, sir.
What is confusing?
So both are the same things.
Both are representing the same thing in a different way, right? जैसे आपका नाम दीक्षिता है, right? आपके घर में क्या नाम है? कुछ और होगा. Whatever it is, don't tell me that. किसी का पेट नेम रहता है, किसी का वो रहता है, some और नेम रहता है, right? जैसे मेरा एक भतीजा है, उसका नाम संदीप है, लेकिन घर में उसको सोनू बोलते हैं. Same thing in a different way. You are using different definition, different names. Meaning is same only. You're just saying कि कैसे define करने का है. You're defining in different way in PC, in different way in thermo, but they are not unrelated.
Yes, sir.
Right? That's why we are finding a relation between them, because that's what is causing confusion, right? Because thermo में they are defining it differently, because उसमें जो हम आगे करेंगे उसमें epsilon की जरूरत पड़ती है. We are always going to use epsilon in thermo to do the calculations, because जैसे कि जितना भी इसमें क्या था, हमने एक्सटेंट Z में conversion में we always look at limiting reactant, right? Conversion in the PC is always defined in terms of limiting reactant, बराबर?
Yes, sir.
Whereas extent of reaction does not depend on limiting reactant. It is same for all the components. ये देखा था हमने कहाँ गया? This is the extent of reaction, right? It does not depend on limiting reactant. We do not define limiting reactant. कोई भी reactant ले लो, कोई भी product ले लो, change in number of moles divided by nu किया तो it is extent of reaction. It is independent of limiting reactant or excess reactant. कोई जरूरत नहीं है define करने की. So it is more a universal definition, I would say, epsilon. Whereas conversion is limiting, or rather constricted or restrained definition, because we always have to first define limiting reactant क्या है, then we have to see कि उसका कितना moles change हुआ और field में कितना था. So it is a restricted definition of कितना progress हुआ reaction का, whereas epsilon is a more universal definition. If I know product कितना बना और ratio और उसका stoichiometric number दिखाया बताए, I can calculate epsilon. I don't need to know reactant क्या है. See the advantage of equation 2?
Yes, sir.
डिफरेंस यही है कि वहां पर हमको लिमिटिंग रिएक्टेंट लेने का है, पहले ये टू सी कर लिमिटिंग रिएक्टेंट कौन सा, रिएक्शन पता होना चाहिए, लिमिटिंग रिएक्टेंट कौन सा है डिपेंडिंग ऑन फीड कंडीशंस, देन सी कि उसका कितना चेंज हुआ मोल्स, कितना रिएक्ट हुआ, एंड डिवाइड बाय फीड कंपोजिशन. बट हियर वी डोंट डू एनीथिंग, वी जस्ट से कि कोई भी ले लो, रिएक्टेंट ले लो, प्रोडक्ट ले लो, कितना मोल्स चेंज हुआ या कंज्यूम हुआ या बना, राइट? ए इज फॉर कंजम्पशन, बी एल इज फॉर formation, doesn't matter. And if you know the stoichiometric number, we can calculate epsilon. So it is more easier, I would say, easier to do epsilon than to do conversion calculations.
Yes, sir.
Okay. Okay, so equation 4 is or relation between z and epsilon, where you know that nu is stoichiometric number. यहाँ पर z ले रहे हैं, when you talk about z, you always talk about limiting reactant, right? But epsilon is for all. तो इसमें लिमिटिंग कुछ करने की जरूरत नहीं है. I think we should remove this limiting. Reactant भी नहीं है. Let me say of reactant or product. And you know that is negative for reactants and positive for products. Right? But you know that Z is always positive. Z is never, conversion is never going to be negative, right? So,
Sir?
Yeah.
सर इक्वेशन 1 and 3 कंपेयर कैसे किए वो नहीं समझ रहा है.
लेफ्ट हैंड साइड सेम है ना दोनों का?
नहीं सर, हाँ तो अनरिएक्टेड को या नहीं क्यों बोला ऐसा?
Unreacted को ना भी analyze at any time. कितना भी, it could be product, it could be reactant. It's not unreacted. Analyze number of moles at any time t. ये रिएक्टेंट के निकाला तो ऐसे डाला है, यहाँ पर पॉजिटिव के लिए, प्रोडक्ट के लिए कोई डिफरेंट हो जाएगा.
हाँ ओके सर.
राइट, बट वी नो दैट Z
सर
is
जेड क्या है?
क्या बोल रहे हो?
कन्वर्जन जेड क्या है सर, कन्वर्जन है क्या?
सो रहे थे क्या अभी तक? इट सीम्स यू आर स्लीपिंग राइट। यहाँ पर पहले डिफाइन किया z क्या है।
सर समझा नहीं था इसलिए पूछा।
समझा नहीं था यानी सो रहे थे, इसमें समझने की कोई बात ही नहीं है। आई मेंशन इट क्लियरली व्हाट इज z, डिफाइन इट क्लियरली इन दिस थिंग बिफोर आई स्टार्ट द डेरिवेशन।
गॉट इट सर।
Okay, so z is going to be always positive and यहाँ पर नेगेटिव नंबर है, बराबर, माइनस न्यू आई एप्सिलॉन अपॉन एन आई जीरो, राइट। So what it means is if you want z to be positive, you should always take absolute value of nu I, because nu I can be negative, it can be positive, right? So if we take absolute value of nu I, we always get right hand side का positive number, and that's why this negative is यहाँ पर positive लिया तो ये negative sign remove हो जाएगा. You don't need to put a negative sign here. This becomes positive, and we can write this equation as z is equal to epsilon upon denominator ni 0 upon absolute value of nu I 0 nu I. Equation 5 और 6 is same. फिर उसको डिनोमिनेटर डाला है, doesn't matter, we can write as equation 5 some absolute value of nu I into epsilon upon ni 0. So if we take any component, reactant or product, and if you know the stoichiometric number, take the absolute value of that number into epsilon divided by initial moles of that number of that reactant or product, and that will give us conversion. ठीक है? Any questions on equation 5? Okay, there are no questions. Let's move forward. Okay, so now let us see if there are more than one reactions. If there is more than one reaction taking place, generally क्या होता है, एक reaction नहीं होता है. If you look at CPT, if you look at CPT में देखा होगा आप लोगों ने, कभी-कभी दो reaction होता है at same time when you manufacture. So there can be multiple reactions at the same time. In this case, what is the relation between mole fraction and extent of reaction? जो हमने निकाला था अभी y equal y and epsilon, that was for one reaction when we calculated for ammonia, right? We looked at only nitrogen plus hydrogen giving ammonia. But if there are multiple reactions, then what do we do? Right? In this case, you know that dni is equal to nu I d epsilon for a single reaction. If there are two reactions, then we can write the same thing for reaction 1 and reaction 2. Right? And if reactant like nitrogen and ammonia, hydrogen are participating in both the reactions, then we can add total change dni of reactant or product is equal to dni for reaction 1 plus dni for reaction 2. Reaction 1 में कितना कंज्यूम हुआ और reaction 2 में कितना कंज्यूम हुआ, right? So we can write this as dni is equal to this one, this plus this, which is nothing but summation of nu ij t epsilon j. That means reaction 1 के लिए epsilon क्या है, reaction 2 के लिए epsilon क्या है, उसके लिए यहाँ पर ये epsilon डिफरेंट रहेगा, ये epsilon डिफरेंट रहेगा, nu i सेम रहेगा, right? This will be say epsilon j here, यहाँ पर epsilon j. Where is reaction 1 यानी epsilon 1, this is epsilon 2. समझ में आया इक्वेशन 1? And nu ij is nothing but
Sir,
stoichiometric. Yeah.
सर म्यू आई क्यों सेम रहेगा?
न्यू आई सेम नहीं रहेगा, यहाँ लिखा है न्यू आई इज डिफरेंट, यहाँ पर न्यू आई जे रहेगा, यहाँ पर भी न्यू आई जे रहेगा, राइट। रिएक्शन 1 के लिए न्यू आई क्या है, रिएक्शन 2 के लिए न्यू एक्शन क्या है, सो वी कैन राइट दिस एज सपोज we have new 1 comma 1 new 1 comma 2 new 2 comma 1 new 2 comma 2, राइट। सो रिएक्शन 1 के लिए न्यू 1 क्या है, रिएक्शन 1 के लिए न्यू 2 क्या है, सिमिलरली रिएक्शन 2 के लिए न्यू 1 क्या है, रिएक्शन 2 के लिए न्यू 2 क्या है। अगर 3 चाहेंगे तो ऐसे 3 4 रहेगा। you'll have different values of new I, new 1 2 3 4 for each reaction, and that is why we are saying this। ये जो है हम n यानी component 1 के लिए, suppose I want to say dn1, right, that will be what, new 1 for first reaction into d epsilon 1 plus new 1 for second reaction into d epsilon 2. Say similarly, you can add for component dn2 will be new 2 for first reaction into d epsilon 1, new 2 for reaction 2 into d epsilon 2, right। Same thing we are writing a summation here, reaction 1 and 2 रहेगा, j is for reaction and I is for component। Any questions on equation 1? So new ij is stoichiometric number of species I in jth reaction, right। So we are writing for both, I mean j के लिए summation कर रहे हैं, reaction 1 और reaction 2 के लिए summation कर रहे हैं for each component, right। And we know that d and I is equal to nu I d epsilon by definition, बराबर। So if we integrate this equation 2, we have derived this equation, ni equal to ni0 plus epsilon I nu पहले derived किया, right। So now if we derive this equation for j reactions, equation 3, we'll get same thing, but we'll have summation over j, जितने भी रिएक्शन है सबके लिए समेशन लेना पड़ेगा हमारे को, समेशन ऑफ न्यू आई जे इंटू एप्सिलॉन जे, जैसे ऊपर लिया था हमने, यहाँ पर वहाँ पर समेशन लेना पड़ेगा, राइट। यहाँ पर एन आई डी एन आई था, यहाँ पर एन आई को एन आई 0 प्लस समेशन ऑफ न्यू आई जे एंड एप्सिलॉन जे एंड समेशन इज ओवर जे रिएक्शंस। Any questions on equation 4? ठीक है। Then if we take total number of moles n is nothing but n is equal to summation of ni0 initial moles, that is for all components, plus that we do double summation for each component, this is our total number of moles, right। So all components के लिए addition करने का है and all reactions के लिए addition करने का है, right। Same thing, nu ij into epsilon j। So we can write this as summation of ni0 for all components nothing but n0 plus, इसको इंटरचेंज किया और कुछ नहीं किया, summation over j all reactions and all components nu ij into epsilon j। इक्वेशन 5 पे किसी क्वेश्चन है? Okay, so let summation of nu ij for all components be equal to nu j, that means for each reaction we can have nu j, कितना हुआ, product minus reactant, sum of stoichiometric number for jth reaction is nu j। So equation 5 will become n equal to n0 plus summation over j, ये है, ये जो ब्रैकेट में है दिस न्यू j इंटू एप्सिलॉन j। ठीक है, any questions on equation 6? So now we can write mole fraction of I component in the mixture. Y is equal to Ni upon N, moles of I divided by total number of moles, which is nothing but Ni upon summation of Ni. And we know what is Ni from equation 4, right? So we can substitute here Ni0 plus summation over J, nu I J into epsilon J, divided by N0, N is summation of Ni is N, from equation 6, N0 plus summation over J, nu J epsilon J. Now this is equation 7. So we can write or find out what is the mole fraction of any component, reactant or product in the mixture if we know epsilon for each reaction. Reaction 1, reaction 2, reaction 3, जितना भी reaction होगा सबका epsilon available रहेगा, initial moles available रहेगा, stoichiometric coefficient available रहेगा, so we can find out what is the mole fraction of the mixture, mole fraction of each component in the mixture. ठीक है? Any questions on equation 7? If there are no questions, then we'll solve one problem which will apply this derivation. Let's see. Okay, so equation example 4 is a gas mixture containing 3 moles of CO2, 5 moles of hydrogen, and 1 mole of water is undergoing the following reactions. CO2 plus 3 hydrogen gives CH3OH plus water, and CO2 plus hydrogen gives CO plus H2O. Develop expressions for the mole fraction of the species in terms of extent of reaction. So that means Y CO2, Y hydrogen, Y CH3OH, Y H2O, and Y CO. Right? यहाँ पर I am not able to hide it, but ठीक है. How to do it? Okay, so take this example. Gas mixture containing 3 moles CO2, 5 moles hydrogen, 1 mole of water. Reaction दिया, develop expression for Y in terms of extent of reaction. Equation दिया है आपको पहले ही, right? Have you written the equation? लिखा है किसी ने equation? नहीं लिखा है. this is the equation. Okay, so this is the equation. Write down this equation. Equation 7 लिख लो आपके पास. Write this down and then solve the problem. yi is equal to ni0 plus summation of nu ij, summation over nu ij, summation over j, sorry, nu ij into epsilon j upon n0 plus summation over j nu j epsilon j. ये इक्वेशन अभी अप्लाई करने का है to find out y for each of the components. लिख लिया क्या सबने equation? Raise your hand when you finish writing
Yes.
the equation. हो गया क्या equation 7 लिख के?
Yes, sir.
Can you hear me?
Yes, sir.
Can you hear me? Yes, no?
Yes, sir.
Yes, sir.
Raise your hand when you finish writing equation 7. Okay, so if you finish writing equation 7, now solve that problem. So we are given a gas mixture containing 3 moles of CO2, 5 moles hydrogen, 1 mole water. That is the initial composition of the reactants. And the reaction is CO2 plus 3 hydrogen gives CH3OH plus water, and CO2 plus hydrogen gives CO plus water. Right? So what we need to find out is why CO2, why hydrogen, why CO, why CH3OH, and why water. 1, 2, 3, 4, 5. Right? So for that you need to find out what is the value of epsilon ij. That means epsilon for CO2 in the first reaction, epsilon for CO2 in the second reaction, epsilon for nu for CO2 in the first reaction, nu for CO2 in the second reaction, nu for hydrogen in the first reaction, nu for hydrogen in the second reaction, nu for CH3OH, nu for CO, nu for water in the first reaction, and nu for water in the second reaction. Right? Once you know nu ij, find out what is nu j. Nu j means what is the nu j sum of nus for each reaction, reaction 1, and sum of nus for reaction 2. And then find out what is n0. n0 क्या रहेगा? What is n0?
Total number of initial moles.
Yes, Viraj, you have any question, Viraj?
No, sir. I accidentally kept that raised hand up.
Okay. So what is the value of NiH0 for each of the components? N nitrogen, CO वगैरह वगैरह. NiH0 क्या है सब कंपोनेंट के लिए पता है आपको?
Yes.
क्वेश्चन है तो पूछो. साइलेंस इज नॉट आंसर. क्वेश्चन है तो पूछो, नहीं है तो प्रॉब्लम सॉल्व करो. सब्स्टिट्यूट द वैल्यूज. सिंपल सब्स्टिट्यूशन है इसमें. एंड फाइंड आउट व्हाट इज द वैल्यू ऑफ मोल फ्रैक्शन ऑफ ईच कंपोनेंट इन द रिएक्शन मिक्सचर in terms of epsilon. And there will be epsilon 1 and epsilon 2. Use epsilon 1 for reaction 1 and epsilon 2 for reaction 2. And if you finish calculation of y, raise your hand. हो गया क्या? किसका हो गया? रेज योर हैंड. और क्वेश्चन है, डाउट है तो पूछो. साइलेंस इज नॉट एन आंसर. इफ यू डोंट अंडरस्टैंड समथिंग, आस्क. किसका हुआ क्या? y CO2, y CO, y CH3OH, y hydrogen and y water. दीक्षिता कितना हो गया आपका?
Sir, y CO2 is 3 minus epsilon 1 minus epsilon 2 upon 9 minus 2 epsilon 1.
Are you able to hear me? आवाज आ रहा है कि नहीं आ रहा मेरा?
आ रहा है सर.
आ रहा है सर.
देवेंद्र कुछ हो रहा है कि नहीं?
कर रहा हूँ सर.
इतना टाइम क्यों लगता है? सिद्धि,
सर कर रही हूँ. सर एक डाउट है, वो एन नॉट क्या है?
n naught is number of initial moles, total number of initial moles, summation of NiH0.
सिर्फ एन नॉट सर.
N naught is summation of Ni0. That means total number of initial moles.
ओके.
For all components का initial moles total किया तो कितना होगा? यहाँ पर क्या दिया है? Ni0 क्या दिया है? Initial moles दिया हमारे को, right? 3 moles of CO2, 5
सर
moles of
9.
9. That's N0 is summation of N for all the components. That means 3 for CO2, 5 for hydrogen, 1 for water. That means 9 N0. Nu का values मिल गया सबको. What are the values of nu for the both reactions?
So for first reaction, mu is -2, and for second reaction, 0.
Yeah, nu is -2, right? For first reaction, 1 plus 1 minus 3 minus 1, that is -2. और second के लिए 1 plus 1 minus 1 minus 1, that is 0.
Sir.
So nu, you know, right? Nu1, nu2, right? Nu ij पता है आपको? Nu ij for first reaction, what is the value of nu for CO2?
-1 ना सर.
-1. Nu for hydrogen?
-1.
हाइड्रोजन के लिए -3 आएगा ना फर्स्ट रिएक्शन के लिए.
हाँ सर, सॉरी.
Nu for CH3OH?
+1.
1.
+1. वाटर के लिए +1, right? Similarly, you can find out nu for CO2 for the second reaction, hydrogen के लिए second reaction के लिए, and you have to just substitute this in that equation. I is for component, J is for reaction, reaction 1, reaction 2, that means J is 1 and 2, right? And I is 1, 2, 3. जैसे यहाँ पर ये I1, CO2 1 लिया, hydrogen 2 लिया, CH3OH 3 लिया, water 4 लिया, तो CO5. That means there are 5 components. That means I is up to 5 and J is from 1 to 2. And you have to write for Y for all the 5 components. That means Y CO2 निकालना है, Y hydrogen निकालना है, Y CH3OH निकालना है, Y water निकालना है और Y CO निकालने का है. So 5 Y निकालेंगे, Y mole fraction निकालेंगे. And denominator is going to be same for everything. ये पहले भी बोला था मैंने. Denominator is not going to change. It's going to remain the same for all the components because we are talking about mixture mole fraction. तो denominator में total moles है वो same ही रहेगा, constant रहेगा. Only numerator is going to change for each component. If you find out denominator once, you don't need to find out again and again. It's going to remain the same. Is that understood? और किसी कोई क्वेश्चन है, डाउट है? नहीं है तो कंप्लीट दिस एट होम. सॉल्व एग्जाम्पल ही है, बट यू हैव टू एक्चुअली डू इट टू अंडरस्टैंड इट. जस्ट रीडिंग द बुक इज नॉट गोइंग टू हेल्प. एक्चुअली करो, देन टुमारो वी विल रिव्यू इट.